PhD in chemical engineering. As we're waiting for folks to chime in, I'll be introducing myself. Anyone that's new here, my name is Dr. Andrew Sanchez. I do have a PhD in chemical engineering, and I go live every single week, Monday through Thursday, to answer your very own STEM questions. Ashley, welcome in. You're the first one into the chat. You can ask me anything related to STEM, including mathematics, chemistry, physics, or calculus, or engineering. Guys, let me pull up the first poll for today. Same questions as last week. What topic should we cover today? I also kind of want to ask another question later on. So I'm going to do 40 minutes on the clock, and that's going to be our question for today. I'm going to wait just a few minutes for people to chime in, and I can see what that will be. So I'm going to wait 5 minutes for folks to chime in, and then that way I can keep track. Today is Monday, October 20th, 2025, and we're going to do a bunch of practice problems today related to general chemistry, AP chemistry, mathematics, and physics. And great, so let's just wait a bit. Isaac, welcome in. Calm, user, and Respawn, welcome into the chat. Good afternoon, everybody. How are we doing? Got my practice questions ready here to get started very shortly. I'm going to hide the chat like this and hide this over here. Alder, first vote in, says A, Gen Chem. All right, you're in for a treat because we're going to be starting off with Gen Chem. Guys, if you're just chiming in, welcome into the chat. My name is Dr. Andrew Sanchez. Poll is active, 40 minutes on the clock. If you want to vote for your question, make sure you invite your friends, share the live stream, invite them over, and tap the poll on the top left of your screen, guys. It should be over here. Let's see if I can move myself. The poll should be on the top left here. Let me unlock this, and the poll should be over here. Hold on, let me put myself on top here. There we go. So the poll is going to be up somewhere up on top over here. Okay, so make sure you tap that. All right, guys, so anyone that's just joining into the chat, welcome in today, guys. Today is Monday, October 20th, 2025. Anyone that's new here, welcome in. My name is Dr. Andrew Sanchez, PhD in chemical engineering. And if you're new here, make sure you comment the word new so you know so we know that you are new. If you've been here before, make sure you comment the lock emoji because you know we're about to lock in. Val's welcome in. Aswad says general chemistry. And Elder says general chemistry as well. Okay, perfect. Thanks for voting, guys. While people are chiming in, let me show you the topics that we plan on covering today. If you've selected Gen Chem, what topic should we do? Should we do stoichiometry, limiting reagents, balancing reactions, thermochemistry, P vehicles, NRT? What suggestions do you have? Guys, today's Monday, October 20th, so here is the plan for today. It is about 6 o'clock my time. And Jackson, welcome into the chat. Claudia, thank you for voting. Guys, if you voted, make sure you actually tap the vote so TikTok can register it on the top left-hand side. It is 6 o'clock p.m. PST or 9 o'clock, 9:10 EST. We're going to start off with some AP Chem or Gen Chem review. Comment down below what topic we should focus on. Is it going to be stoichiometry, thermochemistry, equilibrium, acids and bases? Vote down below. At 7 o'clock, whatever is the winner, we're going to do the next topic at 7 p.m. So make sure you stick to the end and drop your questions up on the website. You can go to engineeringminds.co and select the TikTok live stream to drop your questions. Who's KLA says C. So C is going to be physics. Mohammed says thermochemistry. Okay, so we got one for stoic, one for thermo. Isaac says my chem class is called general, organic, and biochemistry. Can you go over balancing chemical reactions? Okay, so that's basically 2 for stoichiometry. So guys, make sure you stick around. We are pretty much gonna get started with Gen Chem. Like I said, we're gonna do Gen Chem for the first hour or so. So let me get out my notes. I think I'm gonna go ahead and start off with stoichiometry because that's a really popular topic. Eduardo, thank you for the follow. Welcome in. And guys, let me hide this one more time as well. and we are gonna get started in about 30 seconds. But before I do, I just want to introduce myself, make sure we're all on the same page here. Okay, guys, welcome into another Dr. Drew live stream. My name is Dr. Andrew Sanchez, and you're watching Engineering Minds. Anyone that's new here, welcome into the chat. Comment the word new so that we know that you're new. And if you've been here before, comment the lock emoji because you know we're about to lock in. Guys, we got 40 minutes on the clock. Make sure you vote up on the top left-hand side of the screen. Vote for the topic that you want to do today. Is going to be general chemistry, organic chemistry, math, or physics. Guys, my name is Dr. Andrew Sanchez. I do have a PhD in chemical engineering. I go live on TikTok every single week, Monday through Thursday, right around this time, 6 o'clock p.m. PST and 9 o'clock EST. I answer your questions for STEM, including mathematics, chemistry, physics, and more. So if you have a question, make sure you drop them down below. Shoot me a DM and hit that follow button. Guys, this is my website. Go to engineeringminds.co or tap the link in my bio to go to Engineering Minds, where you can engineer your mind. Shouts out Jackson / aka Huel Academy. I'm going to walk you through this and then we'll get started right away. Here's where you can book your free consultation call if you need tutoring. I provide tutoring for various STEM subjects, including Gen Chem, OChem, Calc 1, 2, and 3, AP Physics, College Physics, Calculus-based Physics, Organic Chemistry, General Chemistry, and Engineering. You can see all the resources there for the tutoring plans, book your tutoring session, and you can explore the resources where I have free practice problems, videos, and study guides for various STEM subjects. We got math, physics, chemistry, engineering, none for CS or bio yet, but that's going to be in the future. Last but not least, if you want to join the Discord, it's totally free. Just tap this link that says join Discord. All you have to do is just put your email. And then last but very, very not least, if you want your question answered today, make sure you tap on the TikTok Q&A button and we'll do Q&A at the end of the video. All right, Dirty says new, welcome in. Charlie is back. Shouts out Charlie. And great. We're going to get started for Gen Chem today. Let me bring up the schedule one more time. So make sure you vote up on the top left. We're going to go ahead and start with general chemistry. I want to learn chem, but don't want to go back to school. What do you recommend? Andrew, do you want to self-study for fun? If you want to self-study for fun, first thing you have to do is ask yourself, why do I want to do this? What's my motivation? Is it just for fun? Is it out of curiosity's sake? What in particular about chemistry motivates you? Is it organic chemistry? Is it the thermodynamics? Do you want to learn about how cars work? Do you want to learn how products are made? What exactly about chemistry motivates you? That's going to be your North Star when things get tough. Now, you don't have to go to school to learn chemistry. Okay, you can self-study chemistry online by going to, for example, Khan Academy, doing lots of practice problems, and teaching yourself those topics. Okay, but that would be the first thing. Ask yourself, why would I want to self-study Gen Chem? And what can I do to improve my knowledge there? Okay, guys, so we're going to go ahead and get started on the first topic. I think what we're going to do is do a stoichiometry problem. So I'm going to do a stoichiometry problem if stoichiometry is good. So stoichiometry is including limiting reactants, calculating moles, grams to moles, and balancing reactions. Stoichiometry. If that's a good topic, go ahead and drop a thumbs up down below so I know that we are good to go. Okay, if you guys want to do stoichiometry, that's going to be our first topic today. Please comment down a thumbs up down below. Hey Jared, good to see you. Okay, so first topic. Guys, poll is active. 40 minutes on the clock. We are just getting started today. Make sure you vote up on the poll. 31 minutes left. J-Dong, thank you for the heart me. Okay, first topic is stoics. So if stoichiometry, which again includes reagents, reactants, products, moles, grams, limiting reagents, drop a thumbs up. Okay, guys, perfect. Claudia, thumbs up. Eric, thumbs up. Perfect. Eve, Eduardo. Guys, my last suggestion before we fully get started is if you're taking Gen Chem right now, please do not blindly watch this live stream. Literally get out your notes and literally follow along as if this is a real lecture, because I guarantee that if you follow along, oh my gosh, you're gonna learn more in the next 30 minutes than you have all semester. All right, so the first example we're gonna do is going to be identifying the limiting reactant in a reactant mixture. So we're gonna have this compound called acetylene here. So we're gonna have acetylene here, And acetylene is given by the following compound, C2H2. All right, and it's gonna burn at a temperature of 3,500 degrees Celsius. So this compound is gonna burn, and it's gonna burn at 3,500 degrees Celsius. Now, this is not a thermodynamics question, so we're not gonna need the temperature. This is extra information, but I do want you to think about what the temperature is gonna tell us. Okay, so we're having a burning reaction here for C2H2 and oxygen. And the key word here is going to be a combustion reaction. It's going to be combustion, and combustion means burning. Okay, guys. So we're going to have a recipe. And if you've been here last week, you know that we talk about recipe. And we have a step-by-step process to solve for these reactions. Okay? Jared, if you have any suggestions, please let us know the reaction. We can do that. Okay, guys, so then what we're gonna do is I'm gonna give you two compounds and give you the masses. And again, follow along, see if you can get the calculations as well. This is a college level problem, but I'm gonna break it down whether you're in high school or college. Make it as easy as possible. Okay, so also get out your calculators because we're gonna do tons of calculations here. So I'm setting up the problem first. We have 52 grams of C2H2. And we have 188 grams of oxygen. Okay, we have 188 grams of oxygen. Okay, and this is going to be 188 grams of oxygen. That's all they tell us. We have 52 grams of acetylene and we have 188 grams of oxygen. And what we have to calculate is basically how many grams of excess remaining. Okay, gosh, this is going to be a challenge problem. So guys, one more time, since I see more people are joining in, if you're just joining in, welcome into the chat. Comment the word new if you're new here, and if you've been here before, comment the lock emoji because we're about to lock in for this stoichiometry problem. Guys, if you need help on mathematics, chemistry, or physics, I got you. Just sign up for free tutoring session at the link in my bio, engineeringminds.co. We are doing stoichiometry here today, so highly recommend that everyone tries to follow along. Get out your notebooks as if this is a real lecture, and you're going to learn so much. Guys, first question is, what do we have to do first? Poll is still active, 28 minutes on the clock. Make sure you vote for the next topic. What do we have to do? Vote on the top left here. Vote on the top left here. What's the first thing we have to do, guys? If you've been here before, what's the first thing we have to do that I always tell you? Okay, I'm going to start with step 0. Before we even do anything, we have to do step 0, which step 0 is going to be balance the reaction. Balance the reaction. And we have a problem here because this is a college level problem. Okay, in high school, they're going to give you the reaction, but in college, they may or may not give you the reaction. Okay. So Chloe says, how do you know where to start? I got you. I have a really good tip for you. Eduardo says, divide by molar mass. The Claudia says, where do you get the 52 and 188? This was given. Okay, this was given in the problem statement. So it's going to say 52 grams of acetylene mixes with 180 grams of oxygen. Okay, so how do we get the equation if they didn't tell us anything? They didn't say anything here, so we have to get an equation. So I know I'm going to start with what I have here. I know I'm going to have acetylene. So I'm going to do acetylene here is going to be C2H2. Now acetylene is something that I have, but I don't know what's my products. But I have a key word here. Guys, what's the key word in this? Okay, thank you, Jackson. I missed some questions, guys. If I miss your question, just let me know. So what's the key word here? The key word is combustion. Guys, what does combustion mean? What does combustion mean? Combustion means that we have to add oxygen gas into the reaction, and what are we going to generate? Good. Kukamunga says CO2 plus H2O. So we're going to generate CO2 plus H2O. How did I know that? Because this is called combustion. Combustion is always going to be something, okay, plus oxygen generates CO2 plus H2O. Good. If everyone understands combustion, drop a thumbs up. If you understand combustion, go ahead and drop a thumbs up down in the chat. If you're confused about combustion, let me know. Great. Now we have to balance the reaction, guys. So how do we balance this reaction? Okay, so how do we balance this reaction here? Bifo, thank you for the thumbs up. Guys, we're going to go ahead and balance the C2H2. My tip for you is always balance oxygen last. So I'm going to do oxygen last, save oxygen last. That's my number one tip for you. Okay, save oxygen for last. Okay, and we're going to start by balancing the C. But C is already pretty good here. We have a C here, so I'm going to just do a C2 right over here. Okay, and then I'm going to basically have a 2 on this side and a 2H on that side. That's pretty good as well. Now the problem is I have, let's see, I have oxygen here and then I have 4 oxygen here, so that's going to be 5. So that way I'm going to save my best for last is 5 halves O2. Okay, technically I'm not wrong here. Technically I'm not wrong, but I'm just going to multiply everything by 2 so I can cancel out my 2's. If I went too fast here, let me know. Guys, if anyone has any questions, let me know. Let me know if you understand, okay? If this made sense, drop a thumbs up if you're agreeing with this reaction, okay? If you understand how I balance this reaction, drop another thumbs up down below. Chloe's correct. Add a 2 in front of the O2, okay? And then that's going to be our 5 halves. Let's see, so I did a 5 O2. So this should be balanced here. Now I check 4C on the left-hand side and then 4C on the right-hand side. I have 4H with the 4H and then a 10 O2 and then a 10 oxygen, and then 4 times 2 is 8 plus a 2 oxygen. Okay, Chloe says thumbs up. Kukamanga says thumbs up. Thus says thumbs down. So what part did I confuse you, twins? So double check that these are balanced here. I basically did a C4 here, C4 on the right hand side, and then again H4 is all balanced. So these should be balanced. Okay, great. So now what's going to be the next step, guys? What's going to be the next step? Step 1, that was step 0. I feel like step 0 is just starting with the equation. Okay, step 0 is just balance the equation. Now we're going to do our real step 1. And our real step 1 is I always do start with what we know. Okay, step 1 is start with what we know. Yes, this is a combustion reaction. Start with what we know. And let's change it to start with what we have. Let's change that to start with what we have here. So what do we have? Okay, start with what we're given. So what were we given? Start with what we have. Okay, so I basically have 52 grams of C2H2 and 188 grams of O2. Okay, so I basically have 52 grams of C2H2. And what do I want here? What do I want? I'm going to end with what I want. And so I basically have to get my excess or limiting. Excess, I said grams of excess limiting. I meant to say grams of excess reactant. Okay, grams of excess reactant. That's what I want. So before we do this game plan, we need a game plan because this is going to be a challenge problem, guys. Okay. Okay, this is going to be a challenge problem. So we're basically going to start with grams. We have grams. We got to convert grams into moles. So let's make a game plan real quick. Let's do a game plan, a little side note. Okay, let me move this down. I'm going to make a game plan here. And then the game plan is basically I'm going to convert my grams of reactant, okay, into moles of reactant, right? This is grams of reactant. I'm going to convert this into moles. And then I'm going to do a moles of reactant to molar conversion of moles of product. And then I'm going to back calculate back into grams. Okay, so this is going to be my recipe. And then I'm going to go back into the grams of reactant so I can back calculate the grams of excess reactant, okay? So this is my roadmap here. I'm going to start with my grams of reactant, okay? This is approximately at the college level, but I'm going to try to break it down so that whether you're in high school or college, it's going to be easy to make sense. Exactly. You can tell it's combustion because of a little flame, right? Okay, so now we know it's combustion because we have oxygen, CO2, and H2O. So I'm going to apply my little roadmap here. I have grams of reactant here. Guys, if this roadmap makes sense, drop another thumbs up, okay? If you agree with this roadmap, okay, drop another thumbs up just to make sure we're on the same page here, guys, okay? So I have my little roadmap here. So it says grams of reactant here. I got to convert this into moles of reactant. So how do I convert grams into moles? How do I convert grams into moles? I have 52 grams of C2H2. I got to basically convert this into moles of C2H2. How am I going to do that? Okay, how am I going to convert 52 grams of C2H2 into moles? Okay, well, I got to do some pre-calculations here. I need the molecular weight of each substance. So I'm going to add some extra space down over here. And I'm going to pull up my periodic table. Why? Because my periodic table is my bestie. So I'm going to pull up a periodic table, and then I'm going to basically look up a periodic table. Okay, the periodic table is going to be your bestie for Gen Chem. Okay, so I'm going to look up a periodic table, pull that up here, and I got to look for C2H2. Okay, so I got to look for C2H2. All right, so here's my periodic table, and the periodic table is my bestie for Gen Chem. If you don't have a periodic table for Gen Chem, how are you going to calculate the molecular weights? So my periodic table is my bestie. So I'm going to go to my periodic table. I'm going to say, hey, bestie, how do I get C2H2? Okay, guys, so how many grams per mole is C2H2? How many grams per mole is C2H2, okay? So I'm going to go into my periodic table. I'm going to look for carbon. If I can just zoom this in, there we go. So I'm going to look for carbon, which lives right over here. And so carbon, okay, I know it's a little bit blurry, but that's going to be a 12.001. Okay, Claudia says, I don't get the map. Okay, don't worry, we're doing the map. Okay, the map's going to make more sense after. Okay, you can worry about the map after, and it's going to make sense in just a second. So I'm going to basically say for my C2H2, I have 2 times the carbon, which is a 12.011, plus a 2 times a 1.008. Now, if you want to calculate that out, someone go ahead and calculate that out, okay? Someone go ahead and calculate that out. Jackson already is one step ahead, 26.04 grams per mole. 26.04 grams per mole, okay? And that's going to be our what? That's going to be our grams per mole of acetylene, C2H2, right? So that's going to be our grams per mole of acetylene. Guys, so then what we're going to do basically is now the same exact thing for oxygen. So I have oxygen is O2 gas. So how do I get it for O2 gas? Well, I have 2 times 15.99 is approximately 32 grams per mole of oxygen here, okay? So now I have my grams per mole of oxygen. No problem, no problem. So what we're going to do is now I have grams. Now how do I convert this to moles? Now I have grams. How do I convert this to moles? Okay, T2 on. Thank you for sharing the live. Najma, thank you for sharing the live. Guys, let's keep it going. So now how do I convert this into moles? Now I have my grams per mole. So I got to basically, am I going to divide or multiply? Am I going to divide by my 26.04 grams per mole, or am I going to multiply 52 times 26? Guys, if you think I'm going to multiply, comment multiply. If you think I'm going to divide, comment divide, okay? Okay, so basically, okay, Justin got it. Okay, Justin got it. Okay, good job, good job. So we're going to basically take 52 divided by 26.04. So again, this is my 26.04 grams per mole, right? And 52 divided by 26, that's approximately 2 moles. Okay, that's approximately 2 moles. So this is my first part of my roadmap. Okay, so this is my first part of my roadmap. I basically got my 2 moles of reactant, which is my C2H4. So Claudia said, I don't really quite get the roadmap. But this is where we're at the roadmap here. We went from grams of reactant to moles of reactant. So this is where we're at over here. We're basically at moles of reactant here. So if you guys understand how I got the 2 moles of C2H4, drop another thumbs up here. Okay, good job, Eduardo, dirty, and imperfectly. Everyone said divide. Now I got to do the exact same thing, but I got to check because I got to determine which one is limiting versus excess. So I got to basically do, yes, it's just dimensional analysis. Stoichiometry is literally just dimensional analysis, okay? I got to do my 52. Now I got to do the exact same thing, but I have to calculate it for my oxygen, which I started with 188, okay, grams of oxygen. And what do I got to divide this time, chat? What do I got to divide this time to get moles? Right? Remember, I said I went to my bestie periodic table. I said 32 grams of mole, 32 grams per mole of oxygen. So I got to divide 32 grams per mole here. Right? 32 grams per mole of oxygen. Okay? And so someone needs to please help me calculate 188 divided by 32. So that's going to give me my moles of oxygen. So someone please help me calculate what is 188 divided by 32. Okay. Okay, and then that's going to basically give us our moles of C2H4. Okay, and then if someone's doing that, let me know. Okay, Jackson is on top of it, 5.875. So 188 divided by 32. Yep. Okay. Okay, 5.875, right? So 5.875. So now this is my moles of, okay, now this is my moles of C2. This is basically not my moles of reactant. This is my moles of, yeah, that was my moles of C2H4. Okay, and then my moles of oxygen. Okay, guys, so that was step 1, step 2. So you just divide it by the number on the table. Exactly, Claudia. Do you understand that? You just divide it by the number on the table because that's how we convert grams to moles. Okay, so if everyone's good on this step, do me a favor and drop another thumbs up. We got to stay locked in. We're not even done yet. Okay, all we did was convert grams into moles, but we're on this step here. Okay, so now we're basically converted grams into moles. So if everyone's agreeing so far and this is making sense, drop another thumbs up here. Okay. Thank you, Najmo. Got that 5.875. Okay, Najmo, double check your calculations. Najmo off by a little bit, but that's pretty close. Okay, E is correct, 5.875. So that's moles of O2, 2 moles of C2H4. Thank you, Jackson. All right, guys. So now it's gonna be step 2 here. That was step 1. We gotta start with what we have and then convert grams into moles. Convert grams into moles. Now we're gonna do step 2, and we're gonna do a moles to moles. Okay. This is the hardest part for most people, okay? This is the hardest part for most people. We have grams of reactant. We got to convert moles into moles, okay? This is the hardest part for me, and it's the hardest part for most people, okay? So I'm going to do step 2. Step 2, convert moles into moles. As a matter of fact, I'm just going to get rid of this. I'm just going to get rid of this. And I'm going to get rid of this because we already did that. Okay, and then I'm going to say step 2 is convert moles into moles. Okay, this is going to be moles of reactant. Okay, moles of reactant into moles of product. Okay, this is the hardest part, guys, so let's lock in here. Let's lock in for a second, and so if you're following along, again, make sure you get out your notes. So we said that we have 2 moles of C2H4 and 5.875 moles of O2. And if we go to our product, we said we have 2 moles of C2H2 for every 5 moles of oxygen, which react with to form 4 moles of CO2 to 2 moles of H2O. Guys, I gotta double check that I balanced this correctly. So let's just double check real quick. I have C4, right? C4, H4, H4 here, good. And then O10, this is O10. So we double check that I balanced this correctly. Okay, so we gotta do a mole to mole conversion. Which one do we select? Which one do we select? Are we finding theoretical yield? No, we're not finding theoretical yield, Justin, because we do not know the actual versus theoretical. We are finding the total product. We're trying to find the total product. Could a 3-dimensional frequency table be used to display more complex data sets? Have you, wait, where is that from? Because like that's like the 3rd time someone asked me that, I think. And I don't know where that's from. Okay, so guys, we're gonna go ahead and we're gonna, is that from a TikTok? Okay, and then we're gonna convert moles of reactant to moles products. So we're gonna do 2 moles of reactant. So we're gonna do 2 moles of C2H4. Okay, and then guys, what's the molar ratio? What's the molar ratio here? So this is the hardest part. So what do I multiply this time? What do I want? Okay, what do I want here? What am I gonna put right over here? Okay, this is gonna be the trickiest part. So this is where I really want you guys to lock in. Okay, remember, this is just a recipe, and this is what we were talking about last time. We were talking about recipes, and if you missed it last week, don't even worry, because I recorded the whole thing and posted it on my YouTube channel, so you can rewatch that from last week. When we were talking about recipes, we basically said that we have the recipe is the reaction. So remember, we basically call for 2 moles of C2H2 to produce, I'm going to select water, okay? I'm going to select water, so I'm going to do 2 moles of C2H2 for every 2 moles of H2O. Okay, so I'm going to do 2 moles of C2H2, and I'm going to put it in the bottom. Why? Because I want to cancel out my 2 moles of C2H2. Okay? I keep putting a 4 right here. You got the 2m. Okay, I keep putting a 4, but that's a 2. Good job. Good job. It's going to be a 2 to 2 ratio. There you go. Good job. Does everyone understand that? If you're understanding how I did a 2 to 2 to get 2 moles of water, go ahead and drop another thumbs up. Okay, so that way I can cancel out my moles, and then I can cancel out my 2. That's going to be 2 moles of H2O. Now, this is moles of H2O product formed theoretically from my C2H2. Okay, so again, if this made sense to you, drop another thumbs up. If you're following along and you agree with this calculation, drop another thumbs up. Okay, if you got lost at any point, drop a crying emoji or a pawn emoji. Okay, and let me know at what point you got cooked here. Yes, I'm gonna upload this all to my YouTube channel. I upload all the live streams. Okay, yes, you can use the other product as well. It doesn't matter if I selected water, and as a matter of fact, we're gonna use the other products shortly. Okay, Thomas says I hated this class. Okay, all right. So guys, now we have the moles of product from C2H4. What's the next step here? Okay, what's the next step? We basically used acetylene. Now we got to repeat that for O2. So now we got to repeat that for oxygen. So I'm going to start with my 5.875 moles of oxygen. Remember, if you're confused, always start with what you have. What do I have? I have 5.87 moles of oxygen. So I start with my 5.875 moles of oxygen. Now I go back to my recipe. So what numbers do I put here this time? What numbers do I put here this time if I want to get water here? Remember, I have oxygen and water. So I'm going to go back to my recipe here. So I have oxygen here and water. So I see that I have 5 moles of oxygen for every 2 moles of water. So that's why I'm going to put a 5 and a 2, right? Let me circle that one more time. I basically have 5 moles of oxygen for every 2 moles of water. So that's part of my ratio. That's part of my recipe, okay? Super important that you guys understand this. Super important. It took me years to understand this concept. But once I broke it down into seeing that it's basically a recipe, that's how we break this down much easier. So now we got to do that calculation. Okay. And guys, let me know what is 5.875 times 2 divided by 5. So someone calculate that out, please. Someone calculate that out. Okay, 2 divided by 5 is correct. Good job. 30, and I still don't know what that box is. It literally looks like an apple juice, or like an apple. It looks like a, what is that? It looks like a juice box. It's like an apple juice box. Okay, and then 30. Okay, you're supposed to put the H2O up on top. Oh, okay. I changed the my bad, guys. I put the there we go. So we have 2 moles of H2O up on top, and then very good. So then we have 2.35 moles of H2O. Okay, produced. Okay, produced. The key word is produced. Okay, from oxygen here. Now, guys, here's the question of the day here. So if I have 2 moles of H2O product formed from C2H4 versus 2.35 moles of product produced from oxygen here, which one is the limiting reagent? Which one is going to be the limiting reagent? If I produce 2 moles of H2O from C2H4, which one is going to be the limiting reagent? So if you think that C2H4 is limiting, comment C2H4 limiting. If you think that O2 is limiting, comment O2 limiting. Okay? All right, good job, Eduardo. So C2H2 is limiting. Okay, good job, good job. Dirty Faulkner, C2H4. Good job, Sophie, Eduardo. Goose, thank you for the share. Jess, good to see you. C2H4, Zalk. All right, everyone's saying C2H4. If you said C2H4, now comment why. Why is this one limiting here? Okay? So guys, we basically just calculated from our reagent that we formed 2 moles of the H2O product from C2H4, right? Therefore, 2 moles is less than 2.35, right? So 2 moles is less than 2.35. So therefore, we ran out. We basically consumed everything. So that means C2H4 is limiting. Okay, we consumed it. We ran out. Okay, we basically consumed it. We ran out. Exactly, right? Jess says it's the smallest number. Claudia says it's smaller. Okay, so guys, I keep saying C2H4, C2H2. C2H2. Okay, I keep changing that. 2 into 4. Okay, so now that's our first example, but they didn't care if it was limiting or excess. They said, hey, we need to calculate, we want grams of excess reactant, okay? Okay, so we want grams of excess reactant. So we're still not done. That's why this is a college problem, because this one's extra long. We got to stay locked in. We're still not even done yet here. So now what's the next step? Okay, now what's the next step here? Well, now I can select my moles of H2O formed. So I said 2 moles of H2O product formed. Okay, so I have 2 moles of H2O formed. They basically said, we want grams of excess reactant. So now we're over here in our roadmap. We basically started with grams, we converted to moles, and then we did a mole to mole ratio using the stoichiometry. Now we have the moles of product. Now we have the moles of product, and now we gotta back convert. Okay, we gotta back convert. Okay, I said grams of product here, but we also want grams of excess reactant. So I'm actually gonna adjust this. I actually gotta adjust this this roadmap slightly. Basically have grams of product, and then we gotta basically back convert, okay, moles of product back into moles of reactant, and then back convert into grams of reactant. So now we gotta go backwards here. Okay, if we wanted grams of product, we can get that. But actually they said they want grams of excess reactant. So now we have moles of product, we gotta go back to moles of reactant. So now that I have that 2 moles of H2O, I gotta calculate how much reactant was consumed. So I gotta do step 3. Okay, right? Step 3 is basically convert moles of product. Okay, moles of product into moles of reactant consumed. Right? Because guys, think about it as like a recipe. If I'm making a dish and then I run out of ingredients, that means that it's an excess or limiting here. So I start with my 2 moles of H2O, and now what's my ratio here? Now what's my ratio going to be on this side here, guys? So if I basically have my question mark here, so I need a ratio based on the recipe here. And again, my hint for you is if I start with moles of product, okay, H2O is moles of product, and then I want moles of reactant consumed, what do I got to put up on top here? Okay, what do I got to put up on top here? Let's go back to the recipe here. So let's go back to the recipe here. So who knows the ratio here? I can't believe I failed chemistry. Oh no. I was supposed to take my exam on this, but since Canvas was down, I know Canvas is down all day, wasn't it? Guys, so what's my ratio here? If I have moles of H2O up to moles of oxygen. Oh, Zelk, what is the best way to memorize acids, like naming them? I've been going by the charge and H number. Yeah, kind of like that. That's a good tip. I'm going to go back in a second. Okay, 2,5, 2,5. Okay, good job. Okay, 2C, 2H2. Okay, but we're not going to do C2H2 because that was limiting. We got to do excess, chat. We got to do excess twin because O2 is limiting. Okay, so we got to do limiting here. This is going to be our 5. We have basically our, right, this was our 2 moles of H2O. So I'm going to do 2 moles of H2O for 5 moles of O2 was excess. So I got to go back to excess. Okay, so I'm going to put a 2 down here in the bottom. I'm going to put a 2 moles of H2O on the bottom for every 5 moles of oxygen consumed in excess here. Okay, do you understand why I use excess? Because now I can cancel out my 2 moles and my 2 moles. And perfect, so that means that I basically consumed only 5 moles of oxygen gas. So guys, one more time, if this made sense so far, drop another thumbs up. If you're still following along, drop another thumbs up of how I got 5 moles of O2. How did you get that? Please specific on how you got the ratio. So going back to the ratio, so I have 2 moles of product. So I got to convert my moles of product back to moles of reactant consumed. So I'm going to go back to my recipe here, guys. Remember, the recipe is going to tell us what our ratio is. So if I start with H2O, that's where I included the 2 because I have 2 moles of H2O product formed, the keyword is formed, from 5 moles of oxygen gas. So I have 2 moles of H2O back from 5 moles of oxygen gas. So I'm going backwards now. I'm going backwards, so that's how I did that ratio, 2 to 5. Okay? All right. So how do you know to use O2 and H2O? Because O2 is my reactant and H2O is my product, okay? And I gotta convert my moles of product back to my moles of reactant. Does that make sense? All right, so now I have moles of O2 consumed, okay? Now I have moles of O2 consumed, and what's gonna be my next step here? Chat, what's gonna be my next step here, guys? All right, so now I have moles of O2 consumed. I gotta convert moles of O2 back into grams. So now I'm going backwards. We started with grams and then we got moles. Now I gotta convert moles of O2 back into grams. And now how do I do that? How do I do that? Okay. So I have 5 moles of O2. How do I back convert it into grams? Okay. Exactly, right? Basically multiplied by the molar mass. Who built the periodic table? That was Mendeleev. No, it was not a carpenter. It was a chemist. Okay. And it was basically Mendeleev on a train. He did it on a train. Okay, and so that's going to be 32 grams of O2 per mole. So this time I got to basically multiply that here. Okay, 32 grams of oxygen per mole. Okay, great. So now I have moles of oxygen. So now I got to do 5 times 32, guys. So what is 5 times 32? We are almost done. Someone tell me what is 5 times 32? Okay, what is 5 times 32? It's going to be 160 grams of oxygen. And then the very, very last step, step 5, and we are finally done. Okay, calculate grams remaining. Okay, we basically started with, how much did we start? How much did we start with, chat? We basically started with 188, right? We basically started with 188. Let me write that down and then we'll recap the whole thing. Start with 188 grams, and then we have remaining to calculate based on what was consumed. So remaining is starting minus consumed, because this was consumed. So consumed was 160, right? So 188 minus 160, guys. That's the last calculation and we're done. So someone please calculate 188 minus 160 and we are done, okay? So 188 minus 160 and we are done, okay? It's not 42, no, not quite 42. Try one more time. Good job for trying, but try one more time and we are done. Okay, good job, Sophie. Good job, Zelk. Good job, everybody. We are done. Guys, we're gonna do a recap. Don't even worry if you missed the chat. Welcome in to the chat. My name is Dr. Andrew Sanchez. If you guys are new here, comment the word new so we know that you're new. And we are basically going over stoichiometry and limiting reagents. So I'm going to go over this problem one more time, but if you missed it, don't even worry because I'm recording the whole thing. I'm going to post it on my YouTube channel tonight so you can rewatch the whole live stream from scratch. We started with acetylene burning at 3,500 degrees Celsius to generate to produce CO2 and H2O. Okay, we were given that the reaction contains 52 grams of C2H2 and 188 grams of oxygen gas. Okay, and then we basically had to start with what we have to convert grams into moles, and then moles into moles from product, and then back convert into moles to determine limiting versus excess, and then finally back convert into grams. What's the hardest Jenkin constant in your opinion? Most definitely thermodynamics. Thermodynamics is probably the most confusing subject. You do any heat and mass polymer engineering stuff? I do not. Join the Discord if you guys haven't already. Okay, and then so what we did was we had our 2 moles of reagent and our 5.875 moles of oxygen gas. And step 2 was to convert the moles of reactant into products. Guys, if you don't understand chemistry, make sure you try to study along with me here today so you can explain it in your own words. And then we basically determined that we had 2 moles of H2O formed from C2H2 and 2.35 moles of H2O produced from O2. And you guys cooked that part when I asked you which one was limiting, and everyone said that C2H2 was limiting. Why? Because we ran out of that reagent. So that was less, so we determined that C2H2 was limiting. Okay, guys. And then we basically said 2 moles of H2O was generated as product. Step 3 was to convert the moles of product into the moles of reactant consumed. And we determined it was 5 moles of oxygen consumed. And convert moles of oxygen back into grams. And we found the final answer was 28 grams. quite a challenge problem, but this is again at the college level. I did my best to break it down step by step. So whether you're in high school or college, you can follow along. Guys, we're gonna keep it going. Let's check the results for the poll. Let's check who won. Earlier I asked what topic are we gonna do next. So let's go ahead and see the results now. And guys, it is almost already, guys, today's live stream is flying by. Basically said, what topic should we cover? And we basically said Gen Chem, OChem, math or physics. And the results, drum roll. Okay, we started with Gen Chem, so we're gonna figure out what we're gonna do next. And the winner was 5 votes for Gen Chem, 2 votes for OChem, 2 for physics, and 1 for calculus. So we're basically going to lock in for Gen Chem for another hour. If you like the results of the poll, comment a thumbs up. If we're going to lock in for Gen Chem for another hour, comment thumbs up for Gen Chem. If you think we should do a revote, do a thumbs down, and do another crying emoji, thumbs down, pot for cooking. Okay, because we're about to lock in for another hour for Gen Chem. But before I do, I want to reintroduce myself one more time real quick, guys. My name is Dr. Andrew Sanchez, PhD in chemical engineering. Guys, I graduated with my degree not too long ago, and here I'm out building out my company called Engineering Minds. I go live every single week, Monday through Thursday, to answer your questions for math, chemistry, physics, and engineering. You can drop your questions here on the website. Just tap the link in my bio or go to engineeringminds.co. If you need any tutoring, I got you for subjects including calculus, algebra, trig, calc 1, 2, and 3, pre-calc, Gen Chem, OChem, physics, AP Physics, college physics, calculus-based physics, and engineering, and especially organic chemistry, okay? We're definitely going to keep doing the OChem live streams, but Gen Chem won again this week, so we're going to keep it going for Gen Chem. Guys, here's all the resources you can see for tutoring. You can join the Discord for totally free, and if you're in the Discord, make sure you introduce yourself and drop in your questions there. And then last but not least, the resource library here. Okay, cool, guys. So yeah, that's what I'm gonna try to figure out next. Should we do more stoichiometry or percent yield? Okay, the website is called engineeringminds.co. Unfortunately, I don't do statistics, Nicole, pre-calc, and Gen Chem. Okay, guys, we gotta do another. Oh, Claudia dropped a question here, guys. Okay, Claudia dropped a question here. This is pretty good, guys. I'm gonna do another poll, and then we gotta basically lock in for the next question here. Okay, so okay, let's do another poll, and then I'm gonna basically ask what's the next Gen Chem topic that we're gonna do. So start thinking about that as I pull up this poll, but I do see this problem that I really want to go over. What's the next topic? What's the next topic? And it's only going to be Gen Chem for now because Gen Chem won. So if you did not get that, if you did not get your question, what was that? Percent yield, and then we're going to do thermochemistry, heat, calorimetry, enthalpy, and then Hess's law. Okay, and then someone asked about, what else did I see? Someone asked about VSEPR. Okay, this is bond angles and molecular geometry. Okay, and then I saw one more, guys, lots of requests today, which is really good. Okay, and then we're gonna do other. So this is gonna be the next topic. So we're gonna do another, let's just do another like 10 minutes on the clock. Okay, but I'm gonna get started on that first question that I saw. Gas law, rate laws. Guys, if you really need, guys, if anyone's really cooked, I highly encourage you to sign up for tutoring on my website, guys. Okay, just sign up on my website, or you can DM me on Instagram. Whoops, no, and don't answer that poll. Hold on, start a new poll. We're gonna do another custom poll, and then we're gonna do what's the next topic. Okay, and then we're just gonna put A, B, C, and D, and then we're going to do 10 minutes on the clock. But in the meantime, I'm going to answer that first question that is already here, nice and easy for us to view. Okay, I'm going to do Gen Chem for about another hour. Once again, my name is Dr. Andrew Sanchez. If you have any questions for math, chemistry, and physics, drop them down in the comments below. And 10 minutes on that clock. Vote on the top left-hand of your screen. If you want to do stoichiometry, comment A for stoichiometry. Vote B for thermochemistry, C for VSEPR, and D, make sure you comment other. Thank you, Jackson, for the shout out. Also titration and acids and bases. Okay, so Claudia says, what is the volume of 28 grams of nitrogen gas? Okay. Whoa. Okay. 28 grams of nitrogen gas at STP. Okay, this is going to be pressure. This is going to be your pressure equation. Just as percent yield and stoichiometry. I got you, twin. Where did that go? Okay, what is the volume of 28 grams of nitrogen gas at STP? All right, I think that's all we need here. Okay, that question was on your practice test. All right, twin, got you. So let's lock in together. Okay, I'm going to leave that up and I'm going to try to write small. Okay, so what is the volume of 28 grams of nitrogen gas at STP? Guys, and again, the best way to drop in your questions is to either comment down below, join the Discord, or drop them up on the website. Gas at STP. So let's talk about STP real quick. Guys, what is STP? STP is going to stand for standard temperature and pressure. Standard temperature or pressure. Okay, so what is standard temperature and pressure? What is standard for temperature and pressure? What is standard temperature and pressure, guys? Okay, so standard temperature is basically room temperature. It's going to be 25 degrees Celsius, which is equivalent to 298 Kelvin. So what do I mean by standard? Standard just means that the scientists back in the day said, hey, there you go, 1 ATM. Okay, so STP just means that scientists back in the day said, hey, twin, we gotta come to a consensus. And they said, you know what, twin, you're right. What should we do? Well, we're getting all kinds of numbers mixed up. We don't have a standard. They said, twin, let's just call it STP. Well, what should we make it? Well, 1 ATM, that's 1 atmosphere. And then the other scientist said, you know what, bet, how about 25 Celsius? You know what, that's actually perfect. You know what, cool. So that's standard temperature and pressure. So are we good on standard temperature and pressure? Comment a thumbs up if that was good for standard temperature and pressure. That makes sense. Make some water, chat. Guys, sometimes chemistry and STEM is confusing, but as long as you make it fun, that's gonna make it easier. Okay, so Swam says I don't understand. So one more time, standard temperature is just a set agreed upon standard. A standard just means they said, hey, can we do that? And they said, yeah, bet. Okay, they decided for us. We have no control over it. They decided 200 years ago. Okay. No, 0 degrees Celsius is the freezing point of water, twin. It's not the STP. Okay? Standard means that they picked it. We have no control over it. The scientists, they did it before we were even born. Okay, so the scientists back in the day said, hey, can we just pick a number? And they said, bet. Okay? And so they said that 25 Celsius was the room temperature and 1 ATM was the standard atmospheric pressure. Okay, so our goal is to calculate the 28 grams of nitrogen gas at STP. Okay, so we have a specific volume, guys. So your professors are going to tell you this, but they don't emphasize. They don't tell you to memorize it. I want you to memorize this and box this, especially Claudia, because this is going to be on your exam for sure. So we're going to have the molar volume. Okay, guys, we can prove this. As a matter of fact, I'm pretty sure I have a TikTok where I proved it. So just click on my chemistry playlist to see how this came from. So the molar volume is given by this V with the hat thing, and it's a number that we can calculate, and it's 24 liters per mole. Okay, this is a number, it's a constant, which, guys, if you want me to show you where this number comes from, let me know. We can actually prove this. But this is a number that you have to basically just memorize, twin. Just memorize this. Your professor said, oh, okay, this the molar volume, but they didn't emphasize it. I'm emphasizing for you to please, please, please memorize this number here. Okay, and then if you want me to show where this comes from, if you want me to show the derivation, comment the word show, and then we're gonna do that. Okay? I don't get it. Why did they do this? They did it because they were getting confused and they said, why can't we just agree upon the standard? Why can't we control it? We should get control. Swamp, you actually can. Okay, if you want to change the standard, there's no rhyme or reason why you can't because it's arbitrary. Okay, Juicebox says PV equals NRT, but we're going to do it the easy way. We can do PV equals NRT, but we're going to do it the easy way. Okay? Okay, Claudia says show, Jess says show. Okay, so everyone says show, so let's figure out how to do it the long way then. So guys, you guys said show, so that means we're going to do it the long way. Before we do it the long way, let me do the easy way. Let me do the easy way so we can just get the volume, because we're already almost done. Okay, as long as we have this 22.4, we're actually almost done. So I'm going to start with my 22.4, and then I have my 28 grams of N2. So I'm going to write 28 grams of N2. Okay, this equation calls for moles, so I need to convert grams into moles. So how do I convert 28 grams of N2 into moles? Okay, how do I convert 28 grams of N2 into moles? Guys, 4 minutes left on the clock. Make sure you vote on the top left-hand side of your screen for the next topic for today. Exactly, molar mass. So basically go to my bestie, which is the periodic table. I'm going to say, hey, bestie, what's the molar mass of N2? And then my bestie is going to say, oh, N is right over here. Twin, you need 14. Okay, I know it's really blurry, but it's going to be about 14. Okay, my bestie says, hey, twin, the molar mass of nitrogen is 14, but we need 2 of these. Guys, why do we need 2 of those? Okay, we need 2, right? Because we have 28 grams per mole of N2. Okay, because that's going to be 2 of those for N2, right? So if I have 28 grams, exactly, right? 2 nitrogen. So if I have 28 grams of N2 and I'm going to divide 28 grams per mole, well, that's just 1, right? Because 28 divided by 28 grams per mole, that's just 1 mole, okay? So we're actually pretty much done. So this one was actually not too bad, twin, because we have 22.4 liters divided by moles. Now we have 1 mole of N2. Okay, so I'm going to basically take my 22.4 liters per mole, which is the specific volume at STP, times 1 mole, and my final answer is going to be 22.4 liters of N2. Okay, now everyone says, wait, where did you get that from? Where did you get that 22.4? Now I'm going to show that. Before I show that, drop a thumbs up if you understand how I got the 22.4 liters of nitrogen gas. Okay. Okay, so guys, we're gonna show where that comes from. Okay, we're gonna show where that comes from. So it comes from the ideal gas law. So the ideal gas law is gonna be given by this formula. So the ideal gas law is gonna be given by PV equals nRT. Okay, so the ideal gas law is gonna be given by PV equals nRT. So what are each of the terms in this expression here? What are each of the terms in this expression? So what does P indicate? P is going to stand for pressure, which we already said was 1 atm. Okay, so we have P equals 1 atm. V is what we're trying to solve for. R is a constant. R is a gas constant, and it's given by a number that I also want you to memorize, twin. Is going to be R equals 0.08206 liters times atmospheres per mole times Kelvin. Okay, and then lastly, T stands for temperature, which is going to be in Kelvin. So we're going to use 298 Kelvin. Why? Because I told you STP is going to be 1 atm and 298. Okay, so someone said, hey, why did they choose those numbers? Why can't I do another number? You can. You can choose whatever numbers you want, but everyone chooses these numbers because they're simple numbers. All right. Okay, very good. So we want liters per mole. Our goal is to calculate 22.4 liters per mole. So I'm going to solve this equation for volume divided by moles. Okay, so how am I going to do that? I'm going to take, it's a little bit of math, guys, here, so remember your algebra. So I'm going to show you how to get volume per mole. Okay, I got to divide both sides by what? What do I got to divide both sides by if I want liters per mole? So how am I going to solve for liters per mole? Okay, here's my PV equals nRT. We're going to do PV equals nRT. And then I'm going to basically divide both sides. I got to divide both sides by P here, so I can cancel out my P. Okay. All right, so now I have volume in terms of nRT. Okay, but I also got to divide both sides by my N. So I can cancel out my N and get liters per mole. So this, I told you guys, is the molar volume. So it's R times T divided by P. But wait a second, I already have R, I have temperature, and I have pressure. All I have to do is plug those values in. So I have volume per mole, which is now called a new term called the specific volume, which is going to be 0.08206 liters times atmospheres per mole times Kelvin times the 298 divided by the pressure, which is in 1 atm, and this is in Kelvin. Okay, and if I multiply all those numbers out, I'm going to get 0.08206. So someone please calculate those out. Let me know what you get. 0.08206 times 298, 273. I got something a little bit different. 273. I should have done 273. So I was wrong, guys. So someone said that it was 0 degrees Celsius. Guys, I was wrong. I thought it was 25 degrees Celsius. It's actually 0 degrees Celsius. So whoever said 0 was actually correct. Okay, my apologies. So it's 273 Kelvin. My apologies. So it's 273 Kelvin at 0 degrees Celsius. And so that's going to be my 273. So if you plug that in, guess what you're going to get? That's where the 22.4 comes from. Okay, so the molar volume is going to be 22.4, okay, liters per mole, okay, because all these units cancel out. Kelvin cancels out, we get liters per mole. Okay, yeah, I'm a little bit confused because I thought it was 25, but then when you plug in 25, you don't get that. So I'm a little bit confused here. Okay, I thought it was 25 as well. ATM is the atmospheric, that's a unit. Yeah, it's 1 ATM. Yeah, I'm a little confused. I gotta look into what that actual number was. Okay, I gotta look into that actual number was. Sorry, let me unshare this so you guys can see all that. Okay, but the point is, it's 22.4 moles, liters per mole. Okay, I gotta verify the actual. Let me just double check. What is the molar volume? What is the STP temperature? STP temperature. So it's 25. Oh, so it indeed is 0 degrees Celsius. So I was wrong. 25 is the room temperature. So it's actually indeed 0 degrees Celsius, guys. Okay. So make sure you correct that, please. Please correct that as 0 degrees Celsius. So again, if you plug that all in, you're going to get 0.08206 times 273, and you get 22.4 liters per mole. All right, guys, so cool. We're thinking 20, I know we were both thinking 25 because that's room temperature. All right, guys, we're going to move on to the next topic here, which is going to be thermochemistry. Okay, we're going to do thermochemistry here. So, guys, the next topic that won 2 votes is going to be thermochemistry. If this is a good topic for us to do next, go ahead and drop another thumbs up. If you want to do thermochemistry, including heat, Hess's law, calorimetry, enthalpy, things like that, go ahead and comment a thumbs up emoji. If you think we should do a revote, you're like, no one wants that, say revote. Okay, cool. So last time we talked about calorimetry, last time we talked about Hess's law. So if you missed those, I already posted those on my YouTube channel from the last video, from the last live stream. So what should we talk about this time, guys? Should we do some more examples for Hess's law? Should we do some more practice problems? We can talk about enthalpy. We can talk about the hardest things about thermochemistry, okay, which most likely is going to be enthalpy. Remember, we talked about enthalpy last time. It's going to be delta. This triangle is going to indicate a delta. H is going to stand for enthalpy, okay? Just as a 1% yield, I need to low-key know this too. Where to get practice problems? You can get them on the website, on my YouTube channel, and on the Discord. Okay, guys, let's lock in for enthalpy. Let me just get my book real quick so I can figure out what to talk about. Alright, guys, so I'm going to get some examples for enthalpy. Yeah, I can do NMR for sure. Alright, so let me find a good example for enthalpy real quick. And so I'm going to use my AP Chem textbook here. Alright, so when you see enthalpy, just think energy. Just think of energy. When you see enthalpy, just think energy. Enthalpy, this is going to be in kilojoules per mole. And then think energy. Okay? So guys, we have delta here. So what does the delta indicate? What is the delta here going to indicate? So we have this triangle thing that's called a delta. So what is delta going to indicate? Okay, the delta just simply indicates changing, right? Very good, Evelyn, 30. So difference. So when you see delta H, don't start freaking out. Oh my God, I'm seeing these crazy symbols for thermo. No, don't start freaking out. It just simply means how much is something absorbing? How much is something changing, right? So I'm going to give you guys a reaction. And again, it's going to be at room temperature. And I'm going to give you a reaction. I'm going to give this one as last time for the sake of practice. I'm going to give you C solid. Okay, so don't start freaking out. When you see a reaction with enthalpy, don't start even freaking out. So we have 1/2 O2 gas, and this is going to form CH3OH. Okay, and then we also need a little bit of H2 gas. All right, so this reaction says that we have carbon in a solid form plus 1/2 O2 gas plus 2 H2 gas is going to form CH3OH. This is called methanol. All right, so this reaction just simply, all we're saying here is this reaction is going to consume energy or is going to produce energy. Okay, think about energy, right? When we charge our phones, think about energy as like charging your phone. Okay, that's energy is transferring into charging your phone, right? Same thing here. Same thing for reaction, okay? It's going to take energy. That's like you're using your phone battery or charging your phone. Okay, sometimes it's going to give it energy, right? All right, so I'm going to give you an equation. Okay, I'm going to give you an equation. It's basically going to be the sum of all the enthalpies. Okay, so we want delta H total. We want delta H total. So what is delta H total? Okay, this is the total enthalpy of the system here. Okay, total enthalpy of the system. Total enthalpy change. Let's talk about the concept real quick because I think people don't understand the concept. So guys, we're gonna do a concept real quick. So I'm gonna draw a person, and he's going to be eating. Okay, he's going to be eating a burger, right? It could be a guy or girl or a non-binary, right? Doesn't matter the gender. Okay, this is a person and he's wearing a hat. All right, so he's gonna be eating a burger here, and okay, so the burger is gonna have energy, right? Okay, and then so he's gonna be eating the burger. So let's say this burger is, I don't know, 200 calories, right? 200 calories. Maybe it's a really fatty burger. It's 800 calories. Okay? So this is energy in. This is energy in. This is energy in. Right? But then he goes to the gym. Okay? And then he expends. So now he's running. Right? This is called thermodynamics. We're talking about thermodynamics here. Then he goes to the gym and spends. Okay, so he's running here. He spends. He burns, right? He burns 200 calories. 200 calories. So this is energy out. Guys, so what is the delta H of the system? What is the delta E of the system? What is the total energy change? What is the total energy change? In my, right? I am a burger. I am a burger. Okay? What is the total energy change? Is he more likely going to gain energy, or is he going to lose energy? Okay, so he ate a burger which was 800 calories. That's a lot. And then he justified it and said, don't worry, I'm going to go to the gym. I'm going to burn 200 calories. Exactly, positive, okay? So the change in energy is basically, he basically gained, I like how everyone's saying negative 200 or, okay? So I'm going to basically start with my final. I'm going to basically do energy in. I'm going to call this energy in. I'm going to do E net. I'm going to say energy in minus energy out. So energy in was 800 calories, right? So 800, and then energy out was 200. So he gained 600 calories. So when people justify like, oh, I'm gonna eat this like fatty burger, don't worry, I'm a gym. Well, you better be going really hard to make up for that energy that you gained from that burger. Okay? So guys, if this analogy is making sense for thermo, drop a thumbs up. Okay? If this analogy is making sense, drop a thumbs up, right? He basically gained 600 calories of energy because he ate too many calories from the burger and tried to justify. Okay? Jess, good job. Same for your phone, right? If I'm going to use my phone all day and then I don't charge it, I'm going to lose energy in my phone. So this is called thermodynamics. This is called thermodynamics, guys. So this is the main concept. Now, if this is making sense, guys, it's no different for thermochemistry. It is no different when you're seeing it in chemistry class. You see, delta H means the change in enthalpy. Enthalpy just is another word for energy. Enthalpy is just another word for energy. Think energy for a reaction. So I have this reaction here, and we want the delta H total. We want the delta H total. So instead of doing in minus out, we're going to do a similar equation. Instead of doing in minus out, we're going to do a similar equation, but I'm going to give you some data. So in the problem statement, they're going to give you some data, and then thankfully the scientists back in the day, they gave us some data, and they said delta H equals kilojoules per mole. Okay, so don't even start freaking out when you see all these symbols. Let's break it down. So we already know delta is change, and we know H is enthalpy. Okay, so then the F is going to stand for formation. F is going to stand for formation. So formation just simply means how much energy is required to form a compound product, right? So formation is going to be the energy required to create a product. Okay? So like, let's say you want to make another birthday cake. Okay, because we were talking about making birthday cakes. So delta HF indicates the change in enthalpy required to create a product. The little circle here thing, the little circle indicates a reference state. This is not important. This is more for theory. The little circle just indicates a reference state. This is not important. I want you to focus on the delta HF. Okay? So the scientists went out and they did the experiments for us. They got some data. They said, hey guys, here's the data. I want you to get the net delta H. So the data indicates the delta HF, and they got it for each of those reactants, those compounds. So they said the delta HF for CH3OH, okay, was as follows. It's the symbols that get you. It's the notation. Don't even get confused about the notation. The symbols are just the symbols. So this is going to be given. And so, for instance, the CH3OH is negative 201. The CH3OH is negative 201. Okay? And then the O2 is going to be 0. Okay, so for anything that is diatomic, it's 0. So oxygen is diatomic, it's 0. And then for CO2 is given as negative 394. So if you're saying, where am I getting these numbers? They were given. The scientists back in the day, they did it for us. They calculated it for us. Okay? So they said, all right, twin, here's our data. We want the delta H net. We want the delta H net. So what do we got to do? Okay? Well, just like last time, we said in minus out. So we got to get the total. Okay? Let me zoom out so I can have a little bit more room. Guys, before we get the calculation, any questions about enthalpy so far? Before I get the total, drop a thumbs up if you're understanding enthalpy. Okay? If we're good to go for the calculation, drop a thumbs up. Say good to go. Okay? All right, Scooby, thank you, thank you. All right, so I think we're getting it. I'm going to get the delta H. All right, thank you, thank you. So I'm going to get the delta H total. I'm going to basically say delta H total net is the sum of all the products minus reactants. The products minus reactants. So all I have to do is go to my table and I say, okay, which one is a product? Okay, so guys, is CH3OH a product or a reactant? So the first one is CH3OH. According to the recipe, is CH3OH a product or a reactant? So we memorize the delta HP units? No, you do not need to memorize this. You do not need to memorize this. This will be given. Okay? So is delta H a product or reactant? Okay? So I'm going to do sum of the products minus reactants. So which one's going to be good? Okay, Prissa says product. So CH3OH is product. Good. Jess says product. Leslie says product. Good. So everyone says product. So I'm going to go to my table. I'm going to say products. And then I'm going to say a negative 201. Okay. I'm going to say a negative 201. Okay. But, oh, something is weird here. So guys, they gave us 2 reactions. So let me give you another reaction. Let me give you another reaction here, guys. Oh, okay. So we have CH3OH. Guys, let me give you another reaction because they didn't give me this one here. So I'm going to erase this one. I'm going to give you another reaction. Okay, I'm going to give you another reaction. Sorry. So I'm going to start with 2CH3OH. 2CH3OH plus 3O2. Okay, plus TCO2. So if you're following along, please erase that first reaction and then please correct that one. Thank you. And then now we got to go again. So now we have 2CH3OH plus 3O2 yields 2CO2 plus 4H2O. So I got to use my equation. And let's box that equation so you can have it nice and handy. So that delta H net is the sum of all the products minus reactants. Sum of all the products minus reactants. So I'm going to go my delta H net. And so what's my product this time here? I have 2 CO2. So guys, what's my value for CO2 here? Okay. Exactly. Negative enthalpy is going to be a certain term we're going to call exothermic. Okay. And then positive enthalpy is going to be endothermic. We'll talk about that in a second. Okay, so my delta H net, guys, I'm gonna go to my table here. I have 2 CO2, so I'm gonna go to my CO2 table. I'm gonna say 394. So I'm gonna say a negative, okay, negative 394 times 2. Why did I put a 2 here? Guys, why did I put a 2 right here? Okay, if I said products minus reactants, why did I put a 2 right here? Okay, let me highlight the reaction because that's the main part I want you to focus on. Okay, why did I put a 2 for that? Okay, that's going to be my first step. Okay, 2 moles, good. We have 2 moles of CO2, so that's why I put a 2 right here, because we have 2 moles of CO2, and CO2 is negative 394. Okay, good. And then I'm going to do, what's my other product here? What's my other product? I basically have 4 moles of H2O. Okay, so I go to my table, I say 4 moles of H2O, I'm going to say negative 242 moles of H2O times a 2. Okay, so that's my products. Now I'm going to do minus my reactants. Before I move on to my reactants, does everyone understand how I did products? If you understand how I did products, drop a thumbs up how I did products. Why is it negative? Because this was given in the table here. Okay, this was given in the table as negative. Okay, this is going to be negative in the table here. Okay, good, good. Okay. Oh, I put a 2 here. I got to put a 4 here. Thank you. So I got to put a 4 right here. Okay, and I'm going to try to make my 4s nice and pointy so it's not hard to read. Negative 242 and then a 4. Cool, now I got to do my reactant. So what's my reactant? Well, I have a 0 right here, so anything that's diatomic, I'm going to get rid of that. And so my reactant is going to be a 2. Okay, I'm going to put a 2 times a CH3OH. So my CH3OH is from my table. That's going to be a negative 201. Okay, and then that's going to be my products minus reactants. Okay, would you say this is Gen Chem 1 or 2? I'm not sure because my school was weird. We had it in terms of A, B, C, not 1 and 2. So for me, this was Gen Chem B. So I'm not sure if this is Gen Chem 1 or 2. It's between Gen Chem 1 and 2. My school is weird, so that I learned this in Gen Chem B. But most people don't have A, B, C. Most people have 1 and 2. Okay, so I did negative 1,354 kilojoules per mole if I were to multiply those out. And that's how we do enthalpy, okay? That's how we do enthalpy. If this is helpful, drop a thumbs up. Okay? 30 says Chem 1. Chem 1, but revisited in Chem 2. Chem 1. And you should know this. Then you should know this, okay? Guys, thanks so much for joining. We're still going to keep going for another 30 minutes, but it's been about 90 minutes today. Anyone that's just joining in, my name is Dr. Andrew Sanchez, PhD in Chemical Engineering. I can help you out with math, chemistry, physics, or engineering. You can sign up for a tutoring session at the link in my bio. Just go to engineeringminds.co. Right now we're going over general chemistry. I need to do another poll. To see how we're doing. Thanks everyone for joining so far. Really proud of you guys. Okay, really proud of you guys so far. Super appreciate your interaction. And we're going to do another quick poll today. What topic should we do next? Should we do more examples for thermochemistry, or should we move on to a different topic? If you really need tutoring, make sure you sign up for a session in my link in bio, okay? I don't want you to be cooked. 60 seconds on the clock. Make sure you vote if you want to keep doing more examples for thermo, or if you switch gears here. We basically did stoichiometry for 1 hour, and we're basically doing thermochemistry for another half an hour. And guys, what's going to be the next example here? We got three votes for the same topic. Okay, cool. Nana, good to see you. You have an exam on this? Nana, make sure you check your DM so we can schedule that call, okay? Alright guys, we're going to keep doing thermo as long as you guys vote for that here. So let's try to do some harder examples then. So while you guys are voting, I'm going to look for a harder topic here. Okay, and make sure you hit that follow button so you never miss another live or video. I post videos every single week on YouTube and TikTok. So let's find some thermo to do together. Okay, I want to say the hardest thing is going to be enthalpy and basically like, yeah, these kinds of calculations, Hess's law. Now, do we want to do the beginning? Okay, do we want to do, how should I say this? Do we want to do Hess's law? Okay, let me know. Okay, let me know if we should do Hess's law next or something else. Let's do Hess's law, guys. Guys, if Hess's law is a good thing to go over next, drop another thumbs up. Okay, if Hess's law is another good topic to go next, drop another thumbs up down below. Okay. I post all my videos live on YouTube. Colby caught a mistake I made. Melting is endothermic, so it'll be positive. Okay, guys, I think we're gonna lock in for 30 more minutes, at least 30 more minutes, for Hess's law, and then we're going to go from there. Okay, so one more time, so anyone's new here, you guys can sign up for free consultation call. All the information is there up on the website, engineeringminds.co. Guys, the Discord is totally free. Just click that link that says Discord. The resources are free as well. You can book tutoring. The first session is free, and then you can see all the plans, and here's where you can drop your TikTok Q&A. And my YouTube channel is the same as my TikTok twin. You can just go to the website for the link, or tap the link in bio and click on my YouTube channel. It's just dr.andrewsanchez. And so, guys, we're going to lock in for thermo for another 30 minutes, and then we'll end it for today. But don't worry, I will be back tomorrow around the same time. I go live every single week, Monday through Thursday at 6 o'clock PST, 9 o'clock EST. Okay? And we're basically going to do Hess's law, which is the same idea, but we're going to do some more examples here. So this is going to be more for like reactions. Okay? So hopefully I found a good one here. Okay. Okay. So guys, for Hess's law, it's going to be like a puzzle. Okay? I know, we need more thermo on the website. So would freezing be heat of fusion negative? Freezing be heat of fusion negative? That's a good question. Yeah, I think so too. I think yes. Okay. So guys, I'm gonna give you a bunch of reactions, and they're gonna be balanced already, so we don't have to balance them. Okay, and then we're gonna do B2O3. Okay, so here's our first reaction, and then I'm gonna give you delta H's here. Okay, so again, highly recommend you guys actually follow along. Highly recommend you guys actually get out your notes, follow along, and do the calculations with me. I promise that it may be confusing the first time, but I promise that if you do it multiple times, you're gonna be so surprised and proud of how it's gonna start to make sense. Okay, and then I'm gonna try to make it as easy as possible. So whether or not you're in college, this is a college level problem, but I'm gonna try to make it as easy as possible so that even if you're in high school, you're gonna actually learn how to do this. Okay, so basically gonna generate B2O3, okay, plus 3H2O, okay, plus 3H2O. Okay, so guys, Hess's law is kind of like a puzzle. So let's try to make it as fun as possible. So that way when you make it fun, you actually are enjoying learning and you're going to want to study. If you make learning fun, it's going to be a game changer because you're going to actually want to study. Okay, let's do this as kilojoules. 2035. This is going to be kilojoules. Guys, I'm just writing down this reaction real quick. Bear with me. And I'm going to tell you how to do this. Okay. Okay, so here's our 3 reactions. Let's see, we're gonna have one more, so this one's actually gonna be a little bit harder for first example, so I should have chosen an easier one. So it's gonna be a little bit on the harder side, guys, but don't even worry. We're gonna walk it through step by step. We gotta put the phases as well. So this is liquid, this is gonna be gas, this is liquid, this is gonna be gas. All right. And so while I'm putting the phases, let me tell you the final reaction. So here's all these, here's all these intermediate reactions, and our goal is to basically simplify all of these to produce, let's call this like the final reaction. So the final reaction is 2B solid, okay, plus 3H2 gas. So here's our final reaction. So we're gonna play this kind of like a game. It's kind of like a puzzle. So for this puzzle, we have to combine all of these reactions and their enthalpies to get delta H net. So our goal is we want delta H net. You might think that's impossible. How can we do this with so many reactions? But don't even worry. We're going to basically break it down, okay? All right. Okay. So here we have reaction 1 is 2B solid plus 3O2, okay? And guys, let me put in some of the phases here because I missed that. And guys, what do you think the first thing is we're gonna do here is? What do you think the first thing we have to do here is gonna be? Okay, so I'm gonna put these phases in. This is gas. Okay, so the first thing I have to do is basically I want to cancel out some of these terms so I can get my final product here. So what's my final product? 2B solid plus 3H2 gas is B2H6. So I'm looking for my product here, B2H6. So which one of these reactions, let's call this reaction 1. I'm going to call this reaction 1. I'm going to call this 2, 3, and 4. So where's my reaction here? 1, 2, 3, 4. Where's my reaction here? 1, 2, 3, 4. Okay, 2, 3, solid, H2O gas. Have 2 gas, H2O liquid, liquid. Okay, so where's my product? Okay, I got you. Okay, so I see my B2H6. I'm gonna highlight this on the end product here, right? So guys, I'm gonna highlight this as my product. So I'm gonna select, okay, I'm gonna select this from equation 2. But I see that my product here is B2H6. That's a reactant here. So what if, okay, what if I flip this reaction? So I'm gonna do step 1. Step 1 is flip reaction 2. Okay, flip reaction 2. If I flip reaction 2, now let's see what I would get here. I'd have B2O3 solid, okay, plus 3H2. The reactants become products and the products become reactants. And then I'm going to get B2H6, okay, gas, plus 3O2 gas. Okay, so that's going to be a flip. Now, the key is if I flip my reaction, I also have to flip my delta H. So I'm going to take a negative of that delta H was a, what was that, guys? Negative 2035. So I'm going to take 2035. Okay, so guys, do you see what I did for step 1? For step 1, I flipped reaction 2, and then I took a negative of that value. So I did a negative 2035. Okay, so that's going to be a positive 2035 here. So if you're understanding what I'm doing so far, go ahead and drop another thumbs up down below. Okay, if you're understanding what I'm doing so far, go ahead and drop another thumbs up down below. Thank you, Leslie, for the stickers. Thank you, Leslie, for the live, the good night, and the autumn love. Colby says thumbs up. Oh my gosh, autumn love. I love autumn. I love October, guys. October is so nice. Okay, so I have step 2 here is B2O3 plus 3H2O. So I basically flipped reaction 2. So notice that now I have this one here. So let me highlight that one over here because that's what we want. So this is pretty good. Okay, so that's pretty good. Now, the problem is we still have 3 halves O2. So I want to get rid of the 3 halves O2. Okay? I mean the 3O2. Okay? So I want to get rid of the 3O2. And I want H2 here. I want H2. And I want B here. So I'm basically going to use equation 1. I'm going to basically add equation 1 again. And let's see what I would get. Okay? I'm going to basically add equation 1. I'm going to say 2B solid plus 3 halves O2. It says BS. It says BS, guys. This is not BS. Okay, and that's going to be 2BO3 solid. Cool. So now I have, and that's going to be our regular negative 1273. So I didn't do anything here for step 1. This was a reaction 1. So this was basically a negative reaction 2, and this is a reaction 1. So I basically just made a copy of that, and so I can basically cancel out the 3O2 with 3 halves O2. That's going to give me a 1 half O2 net. So let me just make a note of that here. Okay, if I have 3O2 minus a 3 halves O2, that's going to give me a net 3 halves O2. Okay, because 3 minus 1.5 is 1.5. Is chemical engineering any good? Absolutely. Yeah, it's basically theoretical plumbing. I love it. I love chemical engineering, guys. I think it's the coolest major ever. All right, and then so that's going to be 3 halves O2. Okay, and so that's going to be basically my net for 3 halves O2. Okay, and so I can basically cancel out this guy. So I'm going to eliminate that one. And well, if I have 3 halves here, but I don't want any oxygen here, so I know I can eliminate one of my oxygens. I can multiply this by 3. So I'm going to do step 2 is I'm going to take multiply equation 3 by 3. Okay, so what happens if I take equation 3 by 3? Multiply by 3. Well, I'm going to get 3H2 gas. And someone please calculate negative 286 times 3. Someone please calculate negative 286 times 3. I need to get that. And I'm going to have my 3O2 gas, 3 halves O2 gas, which is going to cancel out. That's what I wanted. That's perfect. That's going to cancel out my halves of O2 gas. Okay, so I can basically eliminate from here and here and eliminate this 3O2. That was what I wanted because I don't want oxygen on the right hand side. Okay, and then that's going to yield, okay, 3H2O, 3H2O. And this is going to be in the liquid phase. Okay, so now that's a problem again because now I have, okay, I have 3H2O in the liquid phase and I have 3H2O in the gaseous phase. Okay, and then I basically have to do a 3 times a negative 286. Negative 286. So Jackson says that's going to be negative 858. Okay, guys, so if we're still so good here, drop a thumbs up. Okay, if we're so far so good here, let's see some thumbs up here because I know this is a little bit tricky. If I confused you, drop a crying emoji or a pot emoji. At what point did you start feeling cooked here? Okay, so now I have 3 times negative 286. Do you know how to find the big O of an algorithm? I do not know computer science very well, my friends. Unfortunately, I'm not very versed in computer science. Okay, the last thing I got to do is basically convert my liquid here. Okay, because I have H2O liquid and H2O gas. Okay, I basically want to multiply by equation 4. I got to multiply equation 4. Equation number 4 by another 3. Okay, so what is that going to give me? So that's going to give me 3H2O liquid yields another 3H2O gas. Okay, because now I can cancel out my liquid, and then I have to multiply that 3, because whatever I do for Hess's law, I have to multiply that for those numbers. Okay, 3 times negative 286. Okay, and then perfect. So now I have, let's see, I can cancel out my 3 moles of H2O gas, 3 moles of H2O gas, and at the end of the day, I have my reaction, guys. So now I'm done. I have the initial reaction, which I started with, because I have B2O3 is going to cancel out as well. See what I mean by puzzle? It feels like a puzzle. So I have 2BS, haha BS. So I have 2BS. Bring that down here. Okay, plus 3H2. That's going to be gas. Yields. My final product is B2H6. Now, we are done with the reaction, so we finished the puzzles. But we have to add these together. So I have a negative 2035. So I have to finish that out. Quantum physics, not yet. Not yet. I want to do quantum physics in the future. And then I have to just get these numbers out. Oh, this one should have been a 3 times a 44. Plus a 3 times a 44. I definitely want to do quantum physics in the near future, though. Right now I'm self-studying linear algebra, so I can self-study quantum physics. Okay, and that's my final answer. I'm going to take 2035. I'm going to take 2035 minus 1273 plus 3 times negative 286 plus 3 times 44. So at the end of the day, I got 36. So my total delta H net is 36 kilojoules. Okay, that's my final answer. Okay, pretty crazy. Okay, so guys, I know this one is a little bit confusing. Okay, this was Hess's law. Okay, but this is the general idea for Hess's law. You start with your whole reaction and then break it down step by step. What questions should I help answer? Do you know any probability and stats for engineering? Twin, you're saying all the topics that I don't know. I know all these engineering topics. I know like thermo, I know heat transfer, but I don't know stats. I don't know quantum yet. I don't know computer science. Okay. But at least not yet. Okay, those are future goals. Where did you get the 2 from? Let's see, which 2? Where did you get the 2 from? Where did you get the 2 from? Calorimetry can be next for sure because we're still on thermo. Let's see, which 2? So the 2 from the B, this 2. So this 2 was here originally. So this 2 was here originally from our final reaction. Okay, this 2 was originally here. If that's the 2 that you meant, that 2 was originally there the whole time. Okay, so to do a quick recap, basically Hess's law was basically just combining the entire reaction to get a sum total of the final reaction here, the delta H net. Yeah, there's definitely, yeah, I forgot about the calorimetry practice problem. Guys, I'm pretty much going to end it soon. I'm going to end it shortly. Thanks everyone for joining so far. This was a really fun live stream for me. We basically did general chemistry for about 2 hours. I'm pretty much going to end it soon, but I will be on for about 5 to 10 more minutes longer. Guys, let me know if this was helpful, and let me know if you guys have any last minute questions. Okay, so guys, all the information is up on the website. We have engineeringminds.co to see all the practice problems that you can download for free. You can join the Discord for free, and you can watch the videos for free up on the website. Just go to engineeringminds.co. And yeah, Colby, so if you want to see the calorimetry problem, just go to engineeringminds.co. Okay, you can again join the Discord, but then click on this link that says Explore Resources. Scroll down a little bit to click Chemistry. And then here we go. This one is pretty popular. Oh no. It says page not found. Okay, but this one over here should be functioning calorimetry practice problem. Okay, I gotta check what happened there. Okay, and then yeah, guys, so I plan on adding tons of resources for math, chemistry, and physics very shortly. Oh no, period. You're just joining in, but we're about to end it, twin. No problem at all. Guys, we did quite a lot today. We basically did general chemistry, and we're locking in. I'm pretty much gonna end it shortly, so I'm just gonna stay on for a few more minutes just to hang out with folks. Guys, how's the semester going for everyone? Are you guys doing all right? Are you feeling good, or are you feeling stressed about midterms? Okay. Guys, if you're feeling stressed, don't even start to worry. Don't even start to panic, okay? I promise I have lots of different things for you all, including live streams every single week, practice problems, YouTube videos, and study guides for you to lock in for Gen Chem, OChem, Math, and Physics. Dr. A, I'm registering for the MCAT tomorrow. You're registering for it? So as in you're not taking it, but you're going to register for it soon? Good luck. Pierre says it's mid. Oh, it's mid. Hey, mid's not bad. Mid's not bad. Jackson says cooked. Okay. Mid is not bad as long as you're not like, you know, totally cooked, right? Oh, it opens tomorrow. I see. Oh my gosh, good luck. I hope you absolutely crush it. Do you have a study plan? Do you have a study plan for the MCAT? I know it has a lot of topics. How long is the exam? Okay, I know it has math, Gen Chem, OChem, physics, and it has like English or something, right? There's like some kind of like analytical something. Oh, and biochemistry, right? February, 8 hours. Oh my gosh. Best of luck. So what you can do is you can set aside 2 hours Monday through Thursday. Put on the live stream right here, but put it on mute. Put it on mute. Don't even listen to the live stream. Don't even interact. Just follow along. Put it on mute. And that's going to be 2 hours every week. 2 hours per day every Monday through Thursday times 4. So that's 8 hours of study time per week just right there. Okay? You can follow along. Psychology, sociology, and critical thinking skills. Reading, yeah. Yeah. So best of luck. Try not to stress about it. I know it can be scary. Applying to med schools can be definitely a daunting process. Okay, I didn't go to med school, guys. I'm not a medical doctor. I'm a PhD, guys. So I have my doctorate, but it's in engineering. It's not in medicine. So I didn't take the MCAT. Okay, so I wish I can give more specific tips, but I will be covering all those topics on the MCAT. So I do Gen Chem, Math, and Physics. I just don't do Bio, unfortunately. Okay. Already graduated. Unsure if I'll take in my gap year. Try to not do one. Yeah, guys, join the Discord. Yeah, Colby, join the Discord if you're not already. I'll shoot a message in when I fix the calorimetry practice problem. Yeah, that'd be great, Jackson. Thank you so much. That'd be great. Guys, I'm gonna be on for about like a couple more minutes. Okay, went on for about 2 hours today. We had 9.6k likes, 40 new followers, got several gifts. Thank you everyone for joining and dropping the gifts. And yeah, guys, so super excited to be out here. I'm just gonna be on just a few more minutes to see if there's any last minute questions. And so yeah, guys, you already know that, you know, when I was in college and high school and undergrad, I struggled a lot with the STEM subjects myself. So ironically, I made it through, got my degree, and now I'm out here because I don't want anyone to struggle or stress just like I was. So if you're feeling stressed or behind, don't feel that way. That's exactly why I'm out here, so you can lock in for these STEM subjects. Guys, these topics, Gen Chem, Math, OChem, Physics, these are not easy topics. So even if you're going through it and you feel that you're like, I'm not smart enough, I'm not good at this, I'm not going to be able to understand this, guys, that's exactly how I felt, the same exact way. So imposter syndrome is definitely real, okay? And it can feel overwhelming at times, but I just want you to know that you're definitely more capable than you realize. It just takes a little bit of lock-in, okay? It just takes a little bit of patience and just locking in, staying consistent with it, right? Just finished my master's on my gap year. Awesome, join how? Colby, you can join the Discord by tapping the link in bio. It says join Discord, okay? Take it when you're ready and enjoy life. There you go. No need to pressure yourself. Okay, guys, pretty much gonna end it here. Thanks again so much for joining. Don't worry, I will be back tomorrow. So super appreciate everyone. Jackson, period, Colby, thank you guys all so much. Leslie, have a good night, my friends. I will see y'all tomorrow. Make sure you drop in the Discord and drop in your practice problems up online. Peace out, my friends. Cheers, cheers. Thank you, thank you. Have a good